Hey, all right, students. Let me try number 63 from number 16, and mostly because it deals with this word intensity. And I didn't get a chance to really mention it here in class. We're kind of rushing here, as we seem to always be, so much material to cover. But the intensity is simply then the power of the waves spread out in some area. And in fact, this was dealt with a little bit in the last chapter, chapter 14, where we were asked to get the power per square meter radiating from the sun in one of those problems. And so if you saw that video solution, you saw me discuss a little bit about intensity. But as in the last video solution I just did in chapter 16, I wanted to address a very common unit called a hertz, which is 1 over a second. So in that one, we had ripples in the ocean, and so the answer turned out to be 40 hertz, meaning the little waves went up and down 40 times every second. So that's a common unit. Maybe you're familiar with it, and we kind of touched on that one. But we didn't get a chance to really talk about the intensity, except, as I said, in that example problem from chapter 14. Anyway, so this is the definition. Good thing about it is the units then would just be watts per square meter. It doesn't really have any fancy name. It's not named after any great scientist or anything. And so it becomes pretty obvious what the intensity is. But like that problem I did in 14, if you have energy radiating from a source, whether it be a sun, or in this one, we're going to see it's a medical application with an ultrasound. But it's that same energy flowing, so same power, now spread out over a bigger area. And so as it moves out, we can use the principle of conservation of energy and yet still say the intensity goes down because it is spread out over a bigger area, which, has its consequences. But anyways, maybe intensity speaks for itself just by saying watts per square meter and kind of drawing a picture of the waves moving out. So anyways, I thought I would do kind of a little lecture intro to this one and then say, okay, let's try this problem. And it says here, an ultrasound has an intensity of 1.50 times 10 to the 2 watts per square meter is produced by a rectangular head of a medical imaging device, which measures 3 by 5 centimeters. So unlike the nice spherical waves that came out in our sun problem back in our chapter 14, these are in this kind of this handheld one. If you've kind of seen these ultrasonic machines, they kind of look like this, and they have kind of a rectangular head, and so you can kind of grab it and put it on the patient. And so maybe this is an ultrasound to maybe look at a developing fetus. So maybe somebody's laying here on their back. What is nose looks like a beak. Maybe someone's head's propped up a little better on a pillow. They got some eyes and an ear. Anyways, the point is I was trying to put this medical device here on the belly so that the sound waves can go in and reflect off, and you can see what's kind of going on inside of the belly. Kidney stones is another good example, and you can see what's going on inside the kidney. Anyway, so in this case, the trick to the problem being a little different, that the area is not spread out over a sphere surface, because in that problem we did 4 pi r squared for the area, but here it's just spread out over a rectangular area. So in one sense, I think that's probably an easier problem. And we don't look at it propagating, so again, probably an easier problem, because they get really indirectly give us the area by saying it's a rectangle and giving us its dimensions, and they already gave us the intensity, and they're after the power. So it's just intensity multiplied by area. That's the trick to the problem, in case you didn't recognize the units, and that's would be my fault because I didn't really get a chance to talk about the intensity. So taking the 1.50 times 10 to the squared watts per square meter, and then multiplying it by the area. Of course, now need to be a little careful, because, again, back to chapter 1, watch your units. We have our area here in centimeters, so if I need to switch that to meters, so I get square meters, so they would cancel with the units of the intensity that they gave me, and would get a unit of watts, which is the unit for power. All right, so grabbing the calculator, 1.5 times 10 to the second, then multiplied by 0.03, multiplied by 0.05. And it looks like then 0.225 watts, or joules per second. So certainly not much energy. Pretty good intensity, that's good, but it's in a small area, so overall the power is on the low side. And low enough that's not going to do any harm, any damage to any person or fetus or anything in there. Okay, hope that one helped.